All right, so by now you should have paused the video, and we're going to focus our attention over here. So setting this problem up, my first term is 3x squared. So the only way to split that apart and get 3x squared is to multiply 3x and x together. So that's going to set up these first spots in each of my binomial sets of parentheses. Then I have to think about what do I need to multiply together to get negative 8. Well, factors that multiply together to get negative 8 are numbers like, I'm just finding some room over here, 4 and 2, where maybe it's a negative 4 and a positive 2, a positive 4 and a negative 2, a 1 and a negative 8, or a negative 1 and a positive 8. So these are all my options of to multiply to get negative 8. I'm going to start with a 4 and 2 combination. I'm first going to start with a minus 4 and a positive 2. I'm just going to start at the top of my list and keep it in order. And let's see how this works out. So beginning to multiply things throughout, I get 3x squared. 3x times 2 is 6x. Negative 4 times x is minus 4x. And negative 4 times 2 is negative 8. Combining the middle terms, which is really where I'm concerned, I end up getting a positive 2x, which is not the 10x that I'm hoping for. So what I'm going to do from here then is I'm going to flip-flop my 4 and 2 and see if that helps or gets me closer to the 8. So I'm going to say plus 2 and minus 4. I'm really concerned with my middle terms, so I'm not going to go through the process of multiplying the 3x by the x this time. Now I'm just going to focus on how I'm going to get that 10x. So I'm going to do 3x times negative 4, which is negative 12x, and then 2 times x, which is a positive 2x. And when I combine those together, I get negative 10x. Well, I'm really close. I get the 10 part, but the sign is wrong. It's negative 10. And in this problem, I should get a positive 10. When this happens, what it means is that you have the right numbers, the right factors, and they're in the right spot, but they have the wrong signs. So what I need to do is I need to flip these signs around, make the 2 negative and the 4 positive. Now that will give me a positive 10x because that'll give me a positive 12x when I do 3 times 4 and a negative 2x when I do negative 2 times x. So now that I have found the proper setup for my factored form, now I can go through and solve for x. So 3x minus 2 equals 0 and x plus 4 equals 0. Add the 2 over and I get 3x equals 2 and divide by 3 and I get x equals 2/3. On this one, subtracting the 4, I get x equals negative 4. All right, that wraps up example 2. Example 3, I want you to take a moment and try example 3 on your own and then press play when you're ready to see the answer. Okay, so taking a look at example 3, we have x squared plus 2x minus 24. This one's a little nicer than example 2 because my value of a is 1. So I know right off the bat when I'm starting my factored form, I'm going to get 0 equals, and x is going to start me off in each of those quantities. Now I'm thinking about the factors of negative 24, that when I multiply things throughout are going to add to be this positive 2x. And that is going to be minus 4 and plus 6. Solving for x, I'd have x minus 4 equals 0 and x plus 6 equals 0. The first one, when I add 4, will give me x equals positive 4, and the second one, when I subtract 6, I'll get x equals negative 6. Taking a look at the next one, setting this one up, I would get 0 equals x, let's see here, minus 10, and x plus 3. Solving for x, I would get x equals a positive 10, and then x equals a negative 3. So at this point, problems like example 3 should be feeling easy for you. If they're not feeling easy yet, then the goal would be at the end of the 7.3b homework assignment that they are starting to feel easier for you. If you're feeling confused by the process, make sure you reach out to myself, Mr. Brasser, or do a little bit more research into what is a method that you can really connect with for factoring. Now we're going to look at something that can be very helpful, and it's considered like a shortcut for when we have binomials. So there's this shortcut that we can use. So if I have a difference of two squares, in other words, if I have some number squared minus another number squared, the shortcut would be A and B, where we take their sum and their difference and we multiply them together. Now this is intended to be a shortcut, and if it doesn't feel good for you, or if it doesn't make the most sense to you, or you don't like the shortcut, then don't feel like you have to use it. This is just there if you think that it could be helpful for you. Let me show how it's applied to a problem. We have x squared minus 9. Well, I could rewrite that to be x squared, minus 3 squared. So notice how I have it set up like I do with that formula kind of that's above, that rule above, where my A is like the x and my B is like the 3. So using that process from above, I can say is factors into x plus 3 and x minus 3. And if you were to multiply this out, you would get x squared minus 9. Again, this is not a method you have to use, but it is a method you can use if you think it would be helpful for you. Another one are called perfect square trinomials. This one is not as straightforward as the last one, and I often find that students really don't like this one until we get into the 2.4 lesson when it's a little bit more applicable. But I want to show it to you just in case it's something that you feel good about and feel good that you can use. So I'm going to set this up by relating this to the example of x squared minus 8x plus 16. So in this one, it also relies on the fact of figuring out an a squared and a b squared, which are your first and your last terms in the quadratic function. So this one, we already have our a set up because that's our x squared. 16, if we were to rewrite it, would be the same thing as 4 squared. So notice that my a is like the x and my b is like the 4 in this example problem. Applying that to this middle term then, it would be minus 2 times a, which is 1x, or just x, times b, which is 4, plus our b squared, which is 4 squared. So because I can set this up and clearly identify what an a and a b is in this problem, I know that this will factor into x minus my b, which is 4 squared. Again, this one is not usually the most straightforward and is likely going to be more confusing for you, and that's okay. I just want to show it to you in case this is a shortcut strategy that you would like to use. This will not work on every problem, but when it meets the specific pattern of a squared minus 2ab plus b squared, it will always factor in the same way of a minus b quantity squared. The very last thing we're going to be talking about today is when we're given the zeros, the values for what x is equal to, and we need to come up with the quadratic function in standard form. Remember, standard form is ax squared plus bx plus c. In this problem, they're telling us that the zeros are 4 and negative 7. So if I were to set this up, that would be, they're telling us x equals 4 and x equals negative 7. Well, now I need to think about what are the factors that those came from. The way I like to approach it is almost like an unsolving approach. X equals 4, so if I want to get this now equal to 0 instead of 4, I need to subtract 4 back over to the other side with x. What that means for me is now my answer of x equals 4 really comes from the factor x minus 4. The answer of x equals negative 7, if I add 7 back over with the side that has x, I get x plus 7 equals 0. So that's coming from the factor of x plus 7. So now I have it in factored form, and now I can multiply my first values together to get x squared, the outer values together to get 7x, the inner values together to get minus 4x, and the last numbers together to get negative 28. Combining like terms, I get x squared plus 3x minus 28, and writing this in function notation, I'll say f of x equals. And that is going to give me my final answer. So I want you to take this knowledge and apply it to example 5. Pause the video, press play when you're ready to see the answer. So we have zeros of 5 and negative 2. That's telling me x equals 5 and x equals negative 2. On solving those, I would subtract 5 over, which is letting me know I have the factor of x minus 5 as part of my answer. The other one of x equals negative 2, if I add 2 over, I get x plus 2 equals 0. So I know that that's coming from the factor of x plus 2. Multiplying everything out, x times x is x squared. X times 2 is 2x. Negative 5 times x is minus 5x. And negative 5 times 2 is minus 10. Combining my middle two terms, I get x squared minus 3x minus 10. And writing this with function notation, I'll say f of x equals. So that wraps up our 2.3b lesson with factoring quadratic functions and then determining a quadratic function from its answer. Please reach out to myself or Mr. Brasser if you have any questions. Thank you so much.